Hello everyone, welcome to the Share Your Green Design podcast. Before we begin today's episode, just a reminder that you can follow and subscribe to us over on Spotify, Apple, or wherever you get your podcasts, and you can also find the full video version of each episode over on YouTube. We're also on Instagram, LinkedIn, Twitter, and WeChat at Share Your Green Design. That's all one word, Share Your Green Design. And remember, the podcast is only one small part of what is an ever-growing platform. So head on over to shareyourgreendesign.com to keep up to date with the latest in sustainable architecture, engineering, and construction. We've got projects, news, research, events, competitions, student work, jobs, everything you need. We'd love to have you as a visitor, but also as a contributor, so you're always welcome to send us your own projects, ideas, events, job openings, and much more. You'll find all the details on shareyourgreendesign.com. Once again, that's shareyourgreendesign.com. Thank you again for your support, and with that, we hope you enjoyed today's episode. Okay, we are here today with Will Arnold from the Institution of Structural Engineers in the UK. How's it going, Will?
Hi, Niall. Yeah, good. Thank you for having me on.
Awesome. No, not at all. Thank you for being here, taking time out of your day. So to kick us off, do you want to give a brief introduction into yourself and also as well into the Institution of Structural Engineers where you're based over there in the UK?
Yeah, sure. So I'm currently working as Head of Climate Action at the IStruct, the Institution of Structural Engineers. We are the world's largest membership organisation dedicated to structural engineering. Got about 30,000 members, about 20,000 or so in the UK and the rest scattered around the globe around various places. And in 2019, our board made the decision to elevate sustainability and put it on a par with structural safety, which for a long time has always been our sort of core focus. So to have these two topics side by side in terms of importance and what we're trying to do with our members and how we help our members, it was quite important for us to be able to sort of push that agenda in every way that we can with guidance and standards and so on and so forth. So my role within the institution really is to go and do that, so to get us thinking about sustainability in everything that we do as an institution and try and get it so that everything our members do in their own work has that same focus.
Mm-hmm. And for yourself then, where did your own interest in sustainability come from? Because I'm right in saying you were at Arup for quite a long time, one of the world's biggest engineering kind of giants. So was sustainability always something that you were interested in, or did it kind of grow over time? What's that kind of background?
It's funny, really. I mean, the people at Arup have been talking about this for a long time. And since I was at Arup, there were always people saying we need to do embodied carbon calculations on everything and all this kind of thing. For me personally, it never really featured in much of my work. For the first sort of 6 or 7 years of my career, I had quite a big interest in timber. That I started developing after I think my first proper timber project was the Macallan Whiskey Distillery up in Speyside, northern Scotland. And then one of the next projects I got involved with, Wadham College, I was quite keen to try and push for timber to be part of the design there, because I thought it seemed like, that would be the more sustainable thing to do. But I never really thought about it much more than that. In 2018, a project came up in Rwanda that I was involved with called the Rwanda Institution for Conservation Agriculture. And what the project was to build an entire university from scratch in the south of Rwanda out of locally sourced low carbon materials. So stone foundations, earth walls, timber roofs primarily, and everything would be sourced locally. It would be built by people who lived in the local area. And the purpose of the university would then be to educate people in sustainable agriculture so that Rwanda can continue to grow as a population without running out of food as a country. I put myself forward to work on that project because I thought it sounded really interesting, the idea of designing this, pretty impressive piece of architecture from earth and from stone and stuff like that.
Yeah.
But whilst working on it, I was sort of exposed to this world of United Nations Sustainable Development Goals and lots of conversations about carbon and things like that. And when I came back to the UK, I just had a bit of a sort of shift of mindset that surely we can do things better here. I mean, if you can build stuff out in Rwanda, a tiny country in the middle of Africa, and you can do it in a way that has a carbon footprint less than half of what we're doing for similar projects in the UK, surely there's got to be room to improve. And off the back of that, I started talking to a lot of people about SDGs. I ended up with an opportunity to do that in front of the institution, which eventually led to this job. And really, the key thing for me was I started trying to work out what the numbers were with all of this stuff. So if I don't fly from the UK to New York, say for that next meeting, how much carbon will that save? If I make a good decision on a project, how much carbon will that save? And I was struck by the realization that there are orders of magnitude difference between the two. I mean, you save a ton of carbon if you skip a one-way flight across the Atlantic, but to save 1,000 tons of carbon on a big project is relatively straightforward for one engineer to do. So really, that just, well, I think once I realised it, I could never sort of unlearn that. And from then on, I've just been trying to do what I can to make sustainability, a bit more a part of everyone's projects.
That point about the difference, say, in carbon savings between, let's say, a lifestyle choice about traveling between, say, London and New York versus construction, I think that's something which is really starting to enter the mainstream awareness. I mean, one of the only big things that came out of COP was the person who said this, I can't remember their name, but they made the point that an architect who designs and sees 3 buildings through to completion will have emitted the same carbon emissions as 164 American lifestyles throughout their life, which is crazy. So just almost to your point, it's rather than trying to change and radically change the 164 lifestyles, there's fierce opportunity in trying to understand how can we make the 3 buildings more energy efficient.
And it's not to say that you shouldn't make those lifestyle changes as well.
Right.
And obviously, what I think one of the most important things you can do on this topic is to talk to other people about what you're doing and why. And so actually, you will influence your families and friends if you start talking to them about why you've decided to stop eating red meat, for example, because it emits so much more carbon than even chicken, let alone vegetables. And why you've decided that for your next holiday you're going to take the Eurostar and then take the train to the south of France instead of flying there. So I'd never say to people don't do that stuff, but I mean the construction of a typical office building in the UK, for every 1 square meter of office that you build, you emit about 1 ton of carbon. God. And yet the yearly emissions of a UK citizen are more in the order of 12 tons of carbon. So you only need to build something 12 square meters in size, and it's equivalent to everything else you will emit for the whole year. And we don't build buildings that are 12 square. I mean, even this tiniest London flat might be 12 square meters, but typically we're involved in projects measured in hundreds, thousands, or tens of thousands of square meters. So you can see it's just completely different scale. So what the decisions you make at work really are, going to make a much bigger impact on emissions than what you can do by recycling or taking your own cup to Costa Coffee and stuff like that.
Exactly, yeah. I want to talk to you about the Part Z building regulations that you've been quite involved in. Just before that, you mentioned Rwanda, which is really interesting because this is only the 4th episode of the podcast, but you're already the 2nd person who has been involved in constructing rammed earth projects in Africa, which is really coincidental.
Who is the other person?
It's Daniele and Raquel Gregorio. They're two architects in Brazil. They do some phenomenal pieces, but they designed a school in I can't remember the country in Africa. It wasn't Rwanda, but it was in Central Africa, I think. But I'm just curious, what was that experience like trying to design and understand material use in Rwanda, material availability? Presumably, it was a lot more challenging than, say, trying to do so in the United Kingdom. Was it difficult for you to kind of immerse yourself in that different traditions, different ways of constructing?
I don't know if it was any more difficult. I mean, working with earth, and it was a mixture of rammed earth, which is when you sort of put up shuttering like you do for concrete, drop earth in small layers at a time, ram it down and keep going until you have a wall. It's a mixture of that and earth block construction. So you make bricks out of earth, leave them to dry just through losing moisture. You don't kiln fire them or anything. And after they're dry enough and they're hard enough, you then sort of stack them as you do brickwork with mortar. The biggest challenges from a sort of technical point of view were to do with the fact that they're not really very well codified as construction materials. And we would have had the same problem over here as if we'd had in Rwanda. And it was slightly harder because you do have small earthquakes there. So there is a sort of moderate seismic loading that we had to design for. And we ended up relying on codes that were written in New Zealand to work with earth in seismic zones. So yeah, I mean, there were technical challenges, but I mean, all projects have technical challenges. I think the really interesting thing about working out there, and in a way, the biggest opportunity that this gave to the designers, was that because there's not so much in the way of precedent of how you should and shouldn't do something like earth construction, it meant that we could really say, well, no, this is the best practice way to build with earth, and sort of set the bar where we needed to set it for this project. It's really interesting that I'm never sure if this was true or not, but it was certainly an anecdote that went around, was that the government had considered banning earth construction earlier in the year before, because it was seen as being a sort of, a material for the poor, a material for people who couldn't afford to live in concrete houses and stuff like that. But by building, we built about 60 buildings out of this stuff. It was just short of 20,000 square meters, and we exposed a workforce on average of about 1,000 people a day to working with this material. Trained all sorts of people up in, how you create earth bricks and how you build masonry properly and how you tie it in with concrete ring beams and foundations, all that kind of thing. And so I think, the hope is that there was a general sort of, awareness that this material can be built with in this way. It's not that complicated compared to normal brickwork. But there are, certain things you have to do with details that are quite important, and hopefully that'll have a lasting impact, and we'll see other buildings in the area built in the same way. In a way, I mean, it's a pretty harsh environment to build in earth, because you get monsoon rains, and the number one rule with earth construction is you have to keep it dry. If it gets wet, it loses strength and it starts to erode. So all of the designs that we worked on, and you probably find it's the same with other precedents you see, would have roofs with really big overhangs. So these big timber roofs with sort of 3-meter overhangs, so we can create tall walls. But if you can keep it dry from the rain, and you can keep it dry from the damp at the bottom by elevating it up, we put it on a couple of courses of fired clay brick. Then it should last, and it should be capable of lasting at least the 50-year design life of the building, if not far, far beyond. So yeah, it was just a case of working through the details, working through some of the technical challenges, and then it was kind of business as usual, albeit you're on the other side of the world and working with work you haven't seen it before. You work through it.
That sounds like a book title: "Business as Usual on the Other Side of the World." I love it.
Yeah, maybe.
Awesome. Let's talk a bit about part-side building rights, because it's something which me personally I'm really actually interested in. To people who, again, aren't maybe not from the United Kingdom, or even who are and who aren't aware of Part C, could you just briefly outline what is Part C building regulations?
Yeah, sure. So for those who are coming at this whole topic completely fresh, the carbon emissions of a building split into two parts, right? There's operational carbon and embodied. Operational carbon are the carbon emissions due to turning on the lights, turning on water, using power, whether it's for your laptop, your air conditioning, whatever. And embodied carbon is kind of everything else. It's anything you can touch, more or less, except water, which I guess is a bit confusing. But your walls, the chair you're sitting in right now, the last door you went through, they're making those materials, transporting them to site, constructing them. That's all got embodied carbon associated with it. And further down the line, repairing, replacing, maintaining, and eventually demolishing them, there's embodied carbon and all of that. In the UK, as with a lot of countries in the world, operational carbon has been regulated for quite some time now. So there are legal limits as to how much operational carbon you can emit per square meter of house. And it's different for different building types and stuff like that, I think. But embodied carbon has never been regulated in this way, and is not regulated in this way anywhere in the world just yet, except the Netherlands, who started doing this in 2012. And there's now a few other European countries that are bringing in regulation on the topic over the next few years. So I think France is due to introduce requirements around this in the next year or two. The reason why it wasn't regulated previously is because operational carbon was always 80-90% of the problem. And so it made a lot of sense to go after it. But the national grid has been decarbonising. Our electricity is much cleaner than it was 10 years ago. And that's going to continue in that direction. We're saying in the UK that the national grid should be fully renewable by 2035. That's the ambition of the government. So by 2035, the only emissions, more or less, that a building will be responsible for is embodied carbon. And there's no regulation on this at the moment. So what Part Z is it's not building regulation. It's an industry proposed amendment to the building regulations. We've got to be quite careful. It's, It's not something that the government have created or backed or anything like that. It's something industry have come together to write and to propose. And we wrote it for two reasons. One, to try and work out in our own minds what regulation on this topic would look like, what the role it would be, and how you go about articulating it as a building regulation. And we actually ended up with quite a short document because it mostly just references existing standards and guidance that we have in the UK. And then the second reason to do it really was to try and work out whether there was industry appetite for this, whether those of us who were talking about writing this just lived in a little bubble where, of course, everyone in your bubble says it would be a good idea. But the second you go out into wider industry, everyone dismisses it. So we wrote it, we put it on the internet. You can find it if you go to parts-z.uk, or if you just Google Part Z. And we put a page on there for statements of support from industry. And we were completely overwhelmed. So to date, we've had 122 statements through, and from really major firms. So that's only one statement per firm. We've had plenty of duplicates through. And the two most recent large firms that have sent us statements of support, one is Arcadis, which is a 28,000 employee engineering firm with a turnover of about 3 million. It's a big turnover. And the other is Aberdeen Investments, which is actually an investment company, but it's the largest active asset manager in the UK, and they've got something like 1 million shareholders. So, really big names supporting this, and they're all saying the same thing, which is that if you can regulate embodied carbon, it will enable the industry to drive it down far quicker than if you leave us to do it on a sort of voluntary basis, because it levels the playing field. It gives you all the same. Everyone has the same requirements as to how this is how you calculate it. This is when you calculate it. This is how you report it. And it puts us all on a level playing field. So it really is something that, the industry has come together behind this and said, we want it. And I was in Parliament on Wednesday this week, trying to make this case in front of the Environmental Audit Committee, which was one of the select committees there. And, hopefully, I don't think you can ignore the noise now in the UK construction industry. People are asking for this, and hopefully Part Z will help sort of show the way for it.
Mm-hmm. Well, people are commenting about, we're recording this in mid-November. The Foster's Tulip building was just rejected by the UK government. One of the things they cited was embodied carbon. Well, they didn't. I don't think they used the word embodied carbon, but it was what they were talking about was embodied carbon. The amount of materials that would go into constructing what was effectively a tall lift shaft with a huge observation deck at the top. So you do start to see some kind of commentary, some kind of awareness from government. That was going to be my next question, which is you make the point, and it's an important point, that Part Z isn't currently it's not in law, it's not part of building regulations yet, it's not enforced. Where are you guys at with Part Z? Are you confident that it will be adopted relatively soon by the government? Have you detected interest amongst Parliament, amongst committees, MPs that you talk to? What is your most optimistic timeline of when we might actually see Part Z in law?
It's pretty hard to say, isn't it? At the end of the day, the Department for Levelling Up Communities and Housing, that's the government department that looks after the building regulations. For them to bring something like this into law, they will have to go through a consultation process, as they do on all of these things. There'll then be a period of writing something before they can bring it in. We know that they and other government departments are well aware that Part Z exists. They're aware now that the industry are behind it. A number of MPs are aware of it as well. And the committee that I was in front of on Wednesday, they're fully aware of what Part Z is and how it works. And our hope is that some of those conversations will now start to happen at government level to ask how this can be moved forwards. Very hard to put a timescale on it, but the point we always make about timescale when asked, when I say we, I mean myself and the other authors of the document, is that the worst thing that a government could do on this topic would be to wait and then try and bring something in really fast. Because whilst a lot of the industry is already doing this anyway, they're calculating carbon on everything and they're trying to set targets on everything. That's not to say that the whole industry is. And of course, regulation means that the whole industry will have to. So there needs to be enough time for the remaining parts of the industry to sort of prepare. And what we've seen in the last 2 years, more or less 2 years since the UK government said we're going to go net zero by 2050, is we've seen this huge shift in the construction industry, particularly amongst the leaders of the industry, where they said, we have to do something. We need to start calculating carbon on everything. And so most of the firms you look at who are now starting to offer this as a standard part of their practice, most of their engineers did not know how to do this 2 years ago and are very, very well equipped to do it now. So, I think that a reasonable timescale would be to say, introduce a requirement to calculate and report carbon on every project in around about 2 years from now, because we know that in the last 2 years, enough firms have upscaled on that. And actually, with a really firm deadline, the progress will be quicker, not to mention the fact we've generated all sorts of guidance in the last 2 years that will help upscale quicker. You impose that in 2 years' time, and then you say another 2 years after that, there will then be carbon limits imposed on the work you do, which would give us a timescale of, bringing it in say 2024 and imposing limits in 2026. There's numbers in the document that we've written. I think they're probably slightly different to that because we wrote it earlier in the year. But that's the sort of timescale we see in mind as being the right balance of ambition and achievability, realistic yet kind of what's needed as an industry.
Exactly. With your kind of structural engineering cap on, then obviously you mentioned you're head of climate action at the Institution of Structural Engineers. How important to you is structural systems, structural materials in climate change, in embodied carbon, and in sustainability? Because even bringing it back, we just mentioned the Tulip Tower by Foster and Partners. One of the things that was cited that they were concerned about was the amount of materials to be used in foundations. So the structural system itself featured quite heavily in that. So, how important do you see structural engineering materials and systems in climate?
So, it won't surprise you to hear me say that. I think they're very important, and there's two real reasons for that. So, firstly, in a typical building, out of all the embodied carbon due to that building, around about 2/3 of that will be the structure. Wow. So that's the first reason why it's important. So, and what that means is that if you could convince a client to refurbish the building that's currently on their site instead of knocking it down and starting again, even if they stripped out everything except the structure, so made it, completely back to the skeleton, reclad it again, you'd make a 60%, 70% saving over starting again, which is, huge. So there are huge wins in terms of overall embodied carbon.
I didn't know that. I didn't know structure accounted for so much.
No, it really is big. Yeah. Obviously, it varies by building.
Yeah, exactly.
But it's in that sort of region. The second reason why it's really important is because typically you're talking about 2 or 3 materials at most. You'll build a whole building, the whole of the structure, the whole of that 60% of embodied carbon will be due to a mixture of concrete, steel, timber, brick. Probably those 4 things, and probably not all 4. Usually, 2, 3, or maybe even 1. So what it means is that unlike, say, the facade system, which might be 15, 20% of the total embodied carbon of the building, but is made up of a really complicated supply chain where you've got rubber gaskets coming from somewhere, glass coming from somewhere else, aluminium panels, insulation, everything, then being assembled, probably being shipped back and forth around the world in the process. Trying to control all of that is relatively hard. Trying to control where your steel frame comes from and your concrete that you pour on top comes from is relatively simple. Now, it's not to say it's simple. Of course it's not. There's still convoluted supply chains because it's construction. It's a big, messy industry. But given that it's at the relatively simple end of the scale, given that it's 2 or 3 materials where once you've decided what material it is, you just have to minimize the amount of material that gets you most of the way there. And given that it adds up to, the largest piece of the pie in terms of embodied carbon emissions, it should be the number one thing that all designers, architects, clients, project managers should be the number one thing people focus on in terms of trying to reduce the carbon emissions off. Because if you can get it down in the structure, that's the quickest way to getting it down in the building as a whole.
Mm-hmm. For new construction, then there's a lot of conversation around, and particularly with concrete, is going through there's quite a process of reflection about how damaging concrete can be versus, say, timber frame systems. Do you agree with that? That concrete, we're going to have to move into a time where we move away from concrete systems, or is that kind of an oversimplistic argument, or what are your thoughts on, say, the environmental performance of all those key materials that you listed?
Key structural materials. I mean, steel and concrete both contribute each contribute something like 7 or 8% to global emissions each. So either of them by themselves, I think if they were a country, they'd be joint third or something after China and the US.
Sorry to interrupt you there, but that's not just like 8% of emissions within construction. Are you talking about
8% of global emissions
overall? Wow.
Yeah. And it's a really big percentage. And I don't have the numbers to hand, but the sort of country league table, if there was one, would go China, USA, concrete, then steel, or steel and concrete. If they were a country, so it really is massive. Steel. Only about half of that goes into construction. The other half goes into cars and washing machines and things like that. But it's still about 4%. So those numbers are, really, really big. There's been a lot of people debating back and forth as to whether you can just replace all steel and concrete with something like timber in the past couple of years. And timber is a pretty difficult topic at the moment in the UK because of what's happening around fire, post Grenfell, and all of that. And we won't get into that in this podcast. But the numbers, the numbers do speak for themselves. And on a typical, low to mid-rise building, particularly one that's sort of domestic scale, where your walls are, at most say 5 meters apart, your columns are 5 meters apart, it's usually the case that you can design that in timber for less carbon emissions than you could in concrete or steel. Now, I have to caveat that because one of the points we tried to make really early on with engineers was that you can't just take any sort of rules of thumb in embodied carbon and then just get on with your job. Unfortunately, it's not as easy as that. So you have to do the numbers because every situation is different. And if you're designing, I just said that for a typical low-rise building, timber would typically be lower carbon. If you're designing a lab where the floors can't vibrate even the smallest amount because microscopes would sort of shake all over the place and you couldn't see what you're looking at, then you might find it's completely unsuitable for it because by the time you put enough timber in to get that floor to stay still, you would have emitted more carbon than if you'd have done it in concrete. So there are, different materials for different situations is kind of the driving force behind this. But yes, I do think there's room for timber as an industry to grow right now in construction. I think that, from a purely carbon point of view, and of course it's not the only metric, but from a purely carbon point of view and emissions today, we would make large savings as an industry if almost all domestic construction was to switch over to timber. There's a big need for this. What we're seeing across all materials, and not just the three I mentioned, but all of them, is material suppliers are stepping up right now. They are saying, well, what part do we have to play in this? In the run up to COP and during COP, we saw decarbonisation pathways and roadmaps announced for the UK steel industry, from the Global Cement and Concrete Association. The timber industry are committing at the moment, I think, to work out how they're going to sort of pledge to get timber's emissions down, because even timber needs to come down to basically zero by 2050. You're seeing the same from brick and glass and everything. So they're all pointing at which way they need to go. I think the really challenging thing with steel and concrete is that with both of those materials at the moment, if you want a low carbon version of that material, and note that it's low carbon, it's not zero carbon, there's still emissions. If you want a low carbon version, you're reliant on a sort of replacement material that's in very short supply. So in steel, the low carbon steels have a high proportion of recycled content. But globally, we produce 3 times as much steel as is available in scrap. So you could never just magic a situation whereby you had more scrap because we didn't have any. So you need to reduce the total amount of steel used. In concrete, you can replace the cement, which is most of the emissions is due to the cement. You can replace that with some other products. But for the most part, particularly in the UK, those are byproducts of the steel industry and from the coal-powered energy generation industry. And those byproducts, not only are they going to sort of go down as we change the way we make energy, the way we make steel, but even now we think we use up everything we make. So with all materials, timber included, steel, concrete included, brick included, the really key thing here is just to use less material in the first place. The less we can use, the more of that limited resource, low carbon stuff there is to go around. The lower the carbon emissions are. I mean, there's a linear relationship between how much material you use and what the carbon emissions look like. And of course, at the moment, we're in the middle of a material shortage in the UK. So there's all sorts of commercial reasons to do this as well. But it takes a bit of a change of mindset to say, well, how do we get the material volume down as low as we can, instead of just aiming for, whatever big architectural ambition we've got? How do we come at this from the point of view of building something that's sensible for the planet, for the climate, as well as the sort of ambition that we want to deliver for the clients, and then approaching it with those sort of dual perspectives in mind.
Mm-hmm. With everything you've seen so far, I mean, you've clearly had a busy career, even though it's not, you're far from the end of your career, but you've already had a lot of experiences and engagements. Are you hopeful or pessimistic about our ability to, within architecture, within engineering, within building design and construction, are you worried or pessimistic about our ability to effectively combat climate change from what you've seen so far?
Am I allowed to say both?
Sure.
I'd say I'm worried and hopeful at the same time. I'm worried because I believe that we need a complete paradigm shift, a complete U-turn in the way we do things. Carbon emissions for years have gone up and up and up, and all of a sudden we're saying they need to come down and down and down. And it really is, it's a sharp U-turn of a corner. We need to change the way we prioritize how we live our lives, how we make ourselves happy. There's this thing called GDP that encourages endless consumption and endless growth.
Yes.
And, it completely needed to change. That worries me. But at the same time, I'm hopeful because, we've got a pretty good precedent of meeting deadlines. Even if it involves an all-nighter, we usually get the end. And humans are incredibly ingenious people. So I don't know if we'll hit 1.5 degrees C, but I know that, the actions we saw even in Glasgow are pulling us in the right direction. Hopefully we'll continue to do so. So fingers crossed it doesn't, we'll get there somehow.
Absolutely. Will, we're really grateful for your time today, for the everything you've shared and everything that you do, be it Part Z, your role in the Institute. Where can people find more information about yourself or about the Institute if they want to?
Yeah, so if you go to www.istructe.org, and particularly if you then put in /climate-emergency, there's a huge amount of guidance that we've created over the last couple of years. It's almost all of it's free. You don't have to be a member or anything. So do go and check that out after you finish listening if you can.
Amazing. Will, thanks a million.
Thank you very much. Cheers.
That's all from us for now. So thank you for tuning into this episode of the Share Your Green Design podcast. Just a reminder before you go, you can subscribe to us over on Spotify, Apple, or anywhere you get your podcasts. Or if you prefer watching the conversation, you can find us on YouTube. You can follow us over on Instagram, LinkedIn, Twitter, and WeChat at Share Your Green Design. That's all one word, Share Your Green Design. And remember, the podcast is only one small part of a much larger platform dedicated to sustainable architecture, engineering, and construction. To keep up to date with the latest projects, news, research, events, competitions, student work and job adverts, head on over to shareyourgreendesign.com. Thank you everyone for your support, and we'll see you next time.